In this video, we're going to get started with the idea of chemical kinetics and talk about factors that affect the rate of a reaction. So, if thermodynamics is the study of which direction a reaction will go, then kinetics is the study of how fast a reaction will get there. So thermodynamics is telling us if you have some reactants, what products will they become? And kinetics is telling us how fast will the reactants become the products. So why would we care how fast a chemical reaction occurs? Well, here's some thoughts, some reasons we might care. We might want to know how long Chernobyl will be radioactive. We want to know how fast those nuclear decay reactions are happening. We might care how fast our new drug candidate is metabolized by the liver, because that'll tell us things like how long will the drug remain in your body before your liver processes it to get it ready for excretion. And you need to balance that with how long until the therapeutic effects are felt. You might care how quickly the nitric oxides from automotive emissions react in the atmosphere, because that can control the production of acid rain and also the global warming effects of those automotive emissions. You might also care how much sarin gas can be destroyed at the Bluegrass Army Depot every day. The Bluegrass Army Depot is in Richmond, Kentucky. And so you might care how long it will take to process the 523 short tons of sarin gas stored there. Okay, so these are all some great examples of why we would care how fast a reaction happens. But so how does a chemical reaction happen? I want you to have a picture in your mind of molecules, and they're in a container and they're all bouncing around. So something kind of like your picture of an ideal gas. You could also imagine them sort of swimming and wiggling through an aqueous solution. So the chemical reactions happen when those wiggly, moving molecules collide with each other. And in order for the reaction to happen, they have to collide with enough energy and with the right orientation. So if they don't hit each other hard enough, then the reaction won't happen. And if they hit each other in the wrong direction, the reaction won't happen. So if you take this picture of how the molecules are all bouncing around, what could you do? What could you change about an experiment in order to increase the rate of that reaction, to make it go faster? So here are some things that you could change to affect the rate of a reaction. The rate of a reaction depends on the nature of that chemical reaction. In other words, what are the specific chemicals? So different chemicals have different reaction rates. And that's just a property of that reaction. It's not really something that we can control per se, but it is something we can learn about a reaction. The physical state of the reaction. So for example, if you have a solid, then if you have a finely divided solid, so little tiny particles, that's going to be faster than if you have one big lump, because if your reaction is happening on the surface, the smaller particles would give you more surface area. The temperature of the reaction is going to matter. So if you're picturing those molecules moving in the container, if you increase the temperature, then they're all going to move faster. And so they're going to collide with each other more frequently and also with more energy. So those collisions will be harder. And so that means that in general, as we increase the temperature, the rate or the speed of the reaction also increases. We can also think about the concentration of the reactants. So in general, if you have more reactants, then you're going to get a faster reaction. Because if you have more particles in your container, it is more likely that those particles are going to find each other and bump into each other in order for the reaction to proceed. And finally, you can add a catalyst. So the point of a catalyst is to speed up the rate of a reaction. And it can do that by a couple of different ways. One way is that it can control the orientation factor. So an enzyme, a biological catalyst, usually does its work by holding the reactants in just the right way so that they can bump into each other properly. Another way might be to make a lower energy requirement for the collision. So make an easier collision. In this class, the ones that we're going to talk about the most are the temperature and the concentration effects. And so we'll talk about concentration in the same session here today, and we'll talk about temperature later.